I'm Andrew Armstrong and welcome to the back of this Teardown Lab sauna, because I left the heating on all weekend and I haven't been in here all weekend, so I am dying. So I feel obligated to make use of that heat by sitting in here and making a video for you. Now these are Velleman kits that my father has procured, as he does, and clearly he wants me to assemble them, which I'm actually happy enough to do. To be honest, these are really good quality kits. So we have the K7000 and the K804, and this is a symmetric 1 amp power supply, whatever that means. And look, there was an optional heatsink which he has purchased. Amazing. Look, it doesn't even fit in the box. You actually did have to buy that separately. 2 times 24 volts maximum input voltage, up to 2 times 1 amp continuous. That's very odd, isn't it? Is that used? It sounds like an audio type thing, doesn't it? In the fact it's got 2. So there's that. We might assemble. Don't know what this is. Probably a part of it. Oh my gosh, big old transformer, heavy. And it's their own branded one, 2 times 12 volts. Okay, we'll put that there. And then we have something which is probably a little bit safer to build, and this is a signal tracer injector. And there are some specs there. It's only difficulty 2. The other kit is difficulty 3. Again, not much on the front and back, because you'd order these normally in the shop or from a catalogue, so you'd have a fairly good idea what they are before you'd get them home even. So what do you think? I think power supplies are power supplies. This is something I could do on the next video perhaps, because it's kind of mundane. You do it and you get some power out of it. But this thing looks like something that does a thing. Let's just crack it open. Crisp. I'm pretty sure they still make these kits. It's not like these are new old stuff. Just from Maplin or Radio Shack Tandy. So you do have a manual. We don't normally read those. Velleman for makers. Oh, it has to be recent because I say for makers. Makers are a recent phenomena, apparently. Okay. But we didn't want to do that. Sure exactly what these do, but there are pieces of equipment I have where if you're testing a bit of a line equipment, you know, like Ethernet cable or some automotive harnesses, you can clip something onto the leads and inject a signal down, like a tone, like a whang, and then you've got a receiver that picks it up. So I'm wondering if this is doing something like that. Of course I could sit and read the manual on it. And I'm just going to see if there's any instructions though telling you what these components are, what the values should be. So the PCB is quite nice. You can have a look there. Nicely laid out, it's nice and thick, very clear silkscreen, single-sided. But we do need to know what the value of the resistors are and things. I'm wondering, oh, online manual. I'm back and it's several hours later. I got a little bit distracted fixing some car stuff, but I did print this out before I left. So these are the instructions and testing sections of the manual. Interestingly enough, it says use the QR code. This thing says use the QR code online to get the information. No QR code, but that's not a problem. You just Google the part number of the kit. So what I'm going to do is use my component tester to just go through the resistors, because that's always an issue for me, is reading the colours off the resistors. But you can see here in the instructions, they do tell you what value for each resistor should be. And I'll probably just do this little bit off camera because I know it's not particularly fascinating. But what I tend to do is use this tool here, which is a, I don't know, leg bender or something. And I'll go through each resistor doing that. So any through hole thing like those power vamp boards, it's lots of this. Then I'll work out the value of the resistor by putting it in here. I can demonstrate that. Just munch it into there and you turn that on. And in a few moments it should figure it out. And that's saying 217 ohms. So let's have a look here. That sounds like a 220 to me. And oh, resistor 1, 220. So we go back to our PCB, look for R1, Where are you? To be honest, sometimes it just takes me longer to figure out where things are like that. And there's R1 right there underneath Zener diode 1. Remember, resistors don't have a polarity, so that's fine. And you pop that in. And I'm just going to repeat that until all the resistors are, and join you again for the soldering stage, because that's far more fascinating. Groovy. That didn't take very long at all. In fact, that's a very slick process. You might think it looks time consuming, but actually if you have the legs already bent, it makes this thing go super quick. So there's my pot of dead legs, by the way. Make sure you keep those. Those are super useful. And interestingly enough, this gets super heavy. I guess it's filled with metal after all. Now you've got these here. What you want to do is flip them any which way you can. So I'm going to just take this manual of sorts and I'm going to flip them over. And you can see them right there. Zoom right in. You can see them all, the legs sticking out. Soldering iron ready. Just taking it off the stand. What should we do? Leaded or unleaded? Let's go for unleaded. Seems more environmentally friendly. So I'm just going to tackle them in no particular order. And if you're worried about the cleanliness of the PCB, before you start, of course, just give that PCB a clean using a bit of IPA. If it's particularly bad, you can rub it down with a bit of steel wool or emery or whatever you've got, just to get that coppery colour back again. But these kits tend to be pretty good quality, and I never really invest any energy in the cleaning side. They tend to be pretty clean. And you can see I'm not using any flux. I'm just relying on the flux in the solder, which again is more than adequate. If you want to get a really super duper artisanal joint made, yeah, go ahead, clean the board, sand it down if it's got tarnish, flux it on each of the little pads. You can go ahead and do that and you'll get a really nice perfect finish. But realistically, you've got to ask yourself, is it worthwhile in terms of the function? Because the thing's probably going to work pretty well either way. Just keep an eye on things when you're doing it, however you're doing it, you know, regardless of whether or not you spend the extra time making it super clean, because you can just tell by eye when a joint's not being made nicely. And there are guides on the internet that say this is a joint with too much solder, this is a joint with too little solder, this is a joint that was dirty, this is a joint that needs flux. So there are guides if you find yourself going wrong more often than you would like. And that's it pretty much. We're down to the last one. And while that's cooling down, I'm going to zoom out. There you go. We get our little pot of goodness. Find ourselves some side cutters, and bear in mind I have broken my Zurons. I need to get some new Zurons. It's so easy to break side cutters by abusing them, and I always end up abusing them. So when you find some good side cutters, and it could be cheap ones, I mean these Duratool ones are okay and they're super cheap, so buy like 3 of them. 4 of them, just keep them on the shelf, whichever is your flavour. Even if you like a £20 Zuron, yeah, okay, it might be a bit expensive. Get 2 of them, because you are really stuffed if you don't have a spare. And normally what happens is you try to munch some thick wire, and I've never had one shear, but what it does, it causes little bites inside the blade there, and those bites will not cut anything. It makes them really gummy, so you can imagine they're going trying to rub their gums off it. And it really gives you a bad day, especially if you've got like 100 boards to make or something, and you're like, oh, you've got to work your way through each one, finding the little bit of the blade that isn't damaged, and then, you know, wiggling it around, convincing the component leg to come off. You don't want to have any of that going on in your life at all. So try to capture as many as you can. You can see I'm dropping them into the tub here. It's quite nice actually, they're not going pinging off the room at the moment. Now, then we can review what we've done. Just inspect it ever so quickly, it's fine. You're just looking for shorts and bridges, so just to make sure that there's no bridging between any of these pads which shouldn't be bridged. If there's no trace between them, make sure they're not touching, but yeah, it's fine. You can hardly go wrong on this. The spacing is nice and generous. So let's look at whatever else we need to do. There's a bunch of electrolytics. There's a couple of transistors. In fact, transistors I don't think we've done for a while, so let's grab the transistors. In fact, it's giving you even the order to do these in, which is super good. The transistors here are both the same. I'm going to ignore that, just show you. Transistors can be a bit cumbersome sometimes because you can order them with the 3 pins in line like this or in this triangle configuration, but I always order the wrong way. It doesn't matter. I'll show you what to do. You can see the picture showing you a flat edge. That aligned to this flat edge of the transistor, so you could see the front of it's flat and then you've got a curve on the back. That's the essential part. What I tend to do, and pay attention now, I tend to try to wiggle it so that the back leg, in fact I'm going to bend the legs slightly so you can see, this back leg is slightly bent, so that allows you to wiggle it into the hole and then wiggle the other legs around it. So once you get it to something like that where they're splayed, just gently wiggle it down, make sure you're supporting it, you don't want it to break or bend in the wrong place, and that will normally see you right. You can see that's in there, it supports itself, and then once you get really good at it, and I'm searching for the next transistor footprint which is here, you can actually just do it in situ. So you see I'm bending the first leg and then I'm going onto the back leg and then going onto the other side. There you go. I can't tell you which is the base, the collector or the emitter, because I can't even tell. I think it's a PNP. It's a BC547. Is that PNP? Anyway, don't matter. It is what it is. We're just making the kit. You don't need to understand it. But if you do want to understand it, in the instructions there is an actual schematic, functional schematic showing you what this thing is doing. So that's kind of cool. Could be helpful in debugging. So those are the transistors. Snip the legs and move on. Let's talk about diodes because they do have a polarity and you need to be careful when you're putting them in. These ones are regular diodes and this little guy here is a Zener diode. And you can see it's glass package as opposed to plastic package like that. Don't worry, you handle them exactly the same way. In fact, I zoomed out too quickly. You will notice they have a band on the one end. That is the cathode end, and you can see it there marked in silver, and you can see it here marked in black. Pay attention to that because that will be critical in the circuit that it goes in the right way. So we're just going to use the same tool. I'm going to bend all of them now. Again, get all your bending done in one go. I've made hundreds and hundreds and hundreds of boards in my time. I can tell you if it's a through hole one, get everything bent up. Get that out of the way. Get it out of your life. So we're going to have a look now for the Zener diode footprint, and it's ZD1. There you go. You can see that right in the corner, and you can see there's a white band on the board that's marking the end of that cathode end. So you're going to line up the black side of that diode on there. And in fact, I used the wrong aperture on our bending tool, so I'm going to have to just wiggle this in. Get in, get in, get in nice and flat. That's good enough. And then you've got the other two diodes, D2 and D1. Much simpler. The picture is very similar to those. And in fact, look, those are slightly wider. So I've gone wrong. I've gone wrong on all of them. But it's not a big deal. Just push them through. Shove them in any which way. The nice thing is when you have made a mistake on the gauge sizing for that, they don't fall out. Makes it super easy to flip over and solder. Now I'm going to get my solder here. Oh dear, this is the leaded solder, so I'm going to do some leaded on these ones to see if they flow any different. Yeah, it flows so good. Leaded solder is so much easier to work with. Oh my word, does that flow. It's crazy. Answers down below on why leaded solder flows so much nicer. I'm guessing it's because lead has a lower melting point than the other alloys they have to use. That'd be my guess. But yeah, answers on a postcard. Because they're a bit of fun, I think we're going to do the capacitors next. Again, we're not following the order that they're specifying in the manual, but if you're doing it, follow their order. They know what they're doing. So you've got 3 10 nanofarad capacitors and 2 100 nanofarad capacitors. So C1, 2 and 3 are this value, so that's handy. I can already see C2 and C3. In fact, I can see C1 as well, so we're just chucking those in. The beauty of these is there's no bending required. The annoying thing is though, when we flip the board, they'll try to fall out, so be a bit careful. So we're going to look for C6 and C7. And the reason we're jumping between C3 and then up to C6 is because we do have electrolytics to fit. Those guys are particularly interesting. Now where is this C6 and C7? How can I not see that? Oh, here. It's so crazy how they can just be invisible but in front of your face. Now I did notice something. There are a couple more capacitors that have a very particular footprint here, and I can see them in the parts. Let's see, are they both the same value? They are. They're both 100 nanofarad, so we can put those in, or at least try to at the same time. Now these could give problems when you try to flip the board. Something I would advise you... Oh, he tried to escape. Something I'd advise you do if you've got one though, when you're working this way, is to get a bit of foam. If you've got something spongy and foamy that you can put on here and flip it over with a bit of compression, that'll really help you out. I'm gonna not do that and see what happens. There we go, that kind of worked. I'll make it work, it's fine. It's all a rockin'. Now if you're doing something like this and you're worried that the placement isn't quite right, just do one leg. Just do one leg of each component and I'll show you why. Do the one leg. I'm trying to work out which is the component. There we go. And that one. And one fell out totally. Let's put that back in. Okay, so now that's in. The reason we're doing the one leg is then you can turn it over and see if they're right. So you see this one's not quite sitting. So I'm just going to push down on it a little bit while I heat the solder. You see that's sitting better now. And these guys are actually okay. I don't think they need adjusting. These little ceramics are all sitting. That's great. So basically the idea is only do one because you can heat one and wiggle it around. You can see me wiggling it around there, make them straight, push them in a little bit more if need be. Not a big deal. It's fine. Let's continue. Finish this up. So we're down to virtually the last few components now. And one of those includes an integrated circuit, which is cool. But the bit that we'll probably take a little bit of care on are the electrolytic capacitors, because they're polarized. And of course, if you watch Star Trek, if you get the polarity wrong of your neutron deflector shields, the Cardassians will get you. Electrolytics, watch the polarity. Always watch it. Keep a close eye on that polarity. You don't want it escaping. So we do have a few flavors here. I'm going to count them up. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. That's good. That's a good sign. So we've got a couple of 1 microfarads. So I'll see if I can spot them, and then I'll show you what I'm looking for in spotting them. So that's a 1 microfarad. And that's a 1 microfarad, right? So when you're looking for them, you're looking at the side of the capsule. Sounds scientific, doesn't it? The capsule. It's time to read the capsule. Oh, there you go. And you can just see 1 microfarad, 50 volts. So that's what you're looking for. And normally it's pretty darn clear on these, what they are. So let's have a look at the board. So you'll see C8 here and C9. There's a little plus by them. Turn it there, you see the little plus? That means you want the positive, which is the long leg. In fact, the negative band is always marked on the can as well. You see the negative there? That means this short leg here is negative. So you're going long leg positive. So if you see on the PCB, it's marked with the positive. Put the long leg in that way. And we know that C9 is the same. So we're going to do the same thing here. Probably for electrolytics, do a couple at a time. And what I like to do with these is grab those lovely long legs and I can plonk it down nice and easily. So 2 is a good number, isn't it? Because that's about the right amount you can grab with one hand. And get in there. Make sure they're soldered up before. And I like to do the one leg thing on these just because it's really nice to get these sticking up nice and vertical. And they are. And we're going to go finish those off like so. Rinse and repeat for the other ones. Now let's start thinking about fitting the integrated circuit, which is an LM386, which I don't know, some sort of amplifier, could be anything. Not a 386 processor, that would be a little bit small for that. Now, instead of putting it directly in, they've kindly put some sockets. And there's your socket. Now you'll notice on the socket there's a little dimple. That dimple has to line up with the dimple in the picture. That just helps you identify the correct end of the IC, because you don't want to put your integrated circuit in back to front. That would be bad. So I'm holding it now with my finger. Now this is how I do it, because just from experience. So I like to keep a bit of solder in the vicinity while I'm holding it. And then I'll tend to just get a bit off the end of the solder and tack one of the ends in. So that's one end in, and then I'll go to the opposite corner, which is here. I'm going to tack that in. And they're not good solder joints. They're pretty lame solder joints, but it's sitting flat. It's where you want it to be. Once you've done that, it just becomes simplicity itself to go and solder the remaining pads. And then you can go and work on those first ones again, which will be shown up now by your superior soldering of the other pads. It's not a big deal. Look, you just do that, hold it again. Just holding it a little bit longer than normal. Let the flux and solder flow, and it's looking good. After that, of course, you want to fit the IC. And the IC is often got slightly splayed legs, so I'm just... it's escaping. I'm just holding it on the deck and I'm just pushing the pins together. So imagine my finger here is the table. I'm just pushing all the pins together so they just line up nicely. Get them parallelized a little bit. I'd say that's good enough. They're not amazingly good, but good enough. Because this isn't a turned pin connector, it's a leaf connector. It's socket. It's much more forgiving of slightly bent pins. Definitely don't start crunching it down until you're sure they look all aligned. And you can see there, that looks that they're all aligned, even though the component's slightly twisted. You can see the pins have gone in where they should. I'm just going to push that down. You can see it's crunched itself in nicely and it's parallelized itself up, so it's going to fit just right. We have the final components now, a couple of potentiometers, and they do come with all of this fitting hardware, so I'm going to take the opportunity, just keep this fitting hardware with them, because you don't want that to get lost. And I wonder if they would have done a nice enclosure for this. If not to worry, you can always make your own. In fact, it sounds like something you probably would do if you're buying this kit and know what it does. I, at the moment, have no idea what this kit actually does. I've just seen them on the shelf. Now, there are two different flavours. You can see here it says 47K. If you've got one of these in your hand, it's nice and clearly written. And this one is 4K7. So they're a whole order of magnitude difference, so don't get them wrong. Luckily, the instructions are saying RV1 is the 4K7, which is this one. So that's RV1. And RV2 must be the other one. So I'm going to make sure they're pushed in nicely all the way. So they're pushed in home. A bit wobbly. Again, this could be a good opportunity to make sure that you just fit one pin, and we'll just check the alignment. I'm going for the center wiper pin on these. To be honest, that's not bad at all. In fact, look, you can see they can be bent in that axis. So you're really just checking they're sitting flat on this axis, and they are. Not a problem. That's why they have fitting hardware. If they're that wobbly, it's the sort of thing you'd want to have in a case. And they are very long. They've left these super generous, so you get some nice knobs on the end of that. Now I am looking, and there are definitely a lot of pins still left, and that's because it does come with these terminals. So these are provided for you to use as little wire wrap terminals, so that you don't have to solder directly to the board. So depending on your usage now, either you're going to fit these or you're not, because you might want to just solder straight here. I'm going to have a little think about this, because these are a little bit of a pain. You might burn yourself fitting them. I looked further in the instructions and they look complicated enough that I want to avoid the testing phase. So I'm just going to continue soldering bits together to take my mind off it. So I'm going to pop these through. They have a pointed end. Put the pointed end through the hole. And you can see the problem is when you flip it over they fall out, so they're just a mega pain. And the downside as well is that when you're holding them to solder, of course they're going to get hot and you might burn yourself. So you can see I've got it perched here and I'm going to just leave it like that and just gently tack solder that end on. But like I said, you want to avoid holding that. If you've got flux, it's probably a good opportunity to you to add that, because of course this is a big old piece of metal and it's probably going to want it. You can see there though, it's actually not bad. It did solder, but it did drop out a little bit. So just take whatever tweezers you've got. Let's provide some force from the back. These are really bad tweezers, but absolutely fine for this purpose. You can see I held it there for a moment, and that's a pretty good pin in there. It's really firm. Nice. Just go around and do the rest. All the pins are connected, so I'm just going to hook up some ancillaries. Luckily enough, I found a battery snap. It might be trickier for me to actually find the battery than the battery snap, but it is 9 volts. So I'm going to just hook up as much of these bits and bobs as I can. I don't know what I'm going to use for test probes and things like that, but we'll work something out. I've not worked out what I'm going to use for probes yet, I have to admit. That's a little bit embarrassing. However, I have realised something. That you remember these fittings for the potentiometer, the hardware? That's because, of course, this is intended to be mounted ideally in a metal case. And of course, being an RF sensitive circuit, you want to be a bit careful. So I thought this is a good opportunity to emulate that case to make sure we don't get any issues. And I'm going to use some of these ring terminals. So really it's a case of attaching a ring terminal and putting a wire to ground. However, I have noticed something in the circuit. The ground pin here, which is this trace here, actually goes to one of the potentiometers on this leg. So I think with a little bit of, well, a bit of arts and crafts, I can do something pretty sweet here. Just bear with me on this. It might work. So I'm going to cut this ring terminal here, snippy snippy, and then show you what I intend to do is just push that through. And if I bend the end of that ring terminal ever so slightly, I'll be able to solder it to that ground. So I'm just going to take the very end in my pliers, and I'm putting a lot of pressure here. I don't want it to kick out. Look at that. That is a nice little angle there. And before I go any further, I'm going to take my soldering iron, and I'm going to use again my leaded solder, but if you don't have leaded solder, just get some flux on there. Let's see if we can get this tinned up. Might be a challenge. You might need to turn your soldering iron up. Oh, no challenge whatsoever. That took absolutely beautifully. So I'm going to post this down now. Oh my gosh, that's so hot. This way, and you can see it's over that terminal there. This is pretty much perfect for what I want. So I'm going to put it gently, and I want to just add it. Oh, it's gone away. I'm going to tin that terminal now. That's the way to do it. So I'm going to actually tin the terminal. As you can see, there's a blob of solder on the terminal. I'm going to align that back over the top of it. I'm going to apply heat to both of those things and let them form a union, an everlasting union of goodness. You can see that there. So now I have a chassis ground point to here, which is super cool. Now I think you're wondering, what are you going to do with the next one? Well, the next one's pretty easy too, because we're going to turn it over and hopefully bridge it over so it can reach the next one. This potentiometer doesn't appear to have a earth. This one doesn't appear to have a handy earth here, so you can't just pinch something off there. You're going to have to just connect it to the other one. That's fine. If this was in a chassis, that's exactly how they'd be mounted, so there's no worries on that score. And we just really need to bridge across to the other chassis here, and I'd like to get it to touch on that terminal because that'd be a good solder point. So I'm just eyeballing that up for length, and it looks like for me it'd be good to take my pliers and unwind this circular part, the crimp connection, and flatten it out. Serendipity, it didn't actually need any tripping. There's a flat edge here on this potentiometer, and you can see that lines up perfectly with a flat edge here. So all we need to do here is apply a little bit of solder. So the trickiest part here is just mounting this somehow. So let's put it here in my big old pot of stuff. Now the camera's definitely going to have trouble deciding on what to focus on, so let's see how it will put up with that. I'm going to put my soldering iron up to 500 degrees. I'm maxing this bad boy out because I want to make sure I can get in and out nice and quickly. So I'm just going to apply some solder on the junction on the edges here between the two, and you can see I'm holding it a little bit longer, because of course it's acting as a humongous heatsink. So you can see there's a nice bridge there. I'm going to turn it over this way. Hopefully we can get a nicer joint on this one, so I can really see this properly. Yes, that's going to do well, I can tell already. You've just got a vibe, you know, you can just feel it when you know you're going to get a good connection, and there is that connection. And this is a very small soldering iron, so that joint is trying to steal that heat away, and it's succeeding for the most part, but we've got that. That's not going to be an issue for us at all. And I guess it has the added benefit of making this a lot more rigid, so that that's nice and tight there. Pop on your hardware again, and then I have to go back to the thing I was trying to avoid, and that's trying to think what to use for probes. We're ready to go. You can see I've attached some wires. I opted not to use a probe at the moment because I didn't have any spare, but if you are going to use any, I can advise you to go onto your usual places, and you can get oscilloscope probes pretty cheap. Like this was a busted one. You can see I've repaired these, but they tend to have a BNC connection. If you're only going to use it for this, you could just cut the wire, and that's fine. These are a coax wire, which is perfect for this application. If not, I think maybe get a nice project box and mount this up properly and put the battery in it, get a couple of BNC sockets so you can plug your probes in nicely. It's all good, you could do it good. So if you see here, I have a battery connected. Ignore this junk on top of the battery, that's my joystick tester. I just didn't have a spare battery, so I'm using that as a source. I don't have an on-off switch, so that's my on-off switch at the moment. Speaker attached. I have a yellow wire for input, a black wire for the ground, and a red wire for the signal. Now, I know you can buy these gadgets online where they're two components and it's like a tenner. So you think, why am I going to make this which has a transmitter and a receiver in one? Well, probably because you're going to want to use it for radios or electronics. So here is a piece of electronics, and let's see how we would hook this up. Now I'm going to solder this. Again, maybe your probe should be the oscilloscope probe, but maybe your main wires don't need to be. You could just use a bit of coax and then solder it straight to your board. But the idea is, if you look at this PCB, you're going to connect ground somewhere. We're going to decide that this is the chassis ground because it's a bit of a ground plane, and that seems about right. In fact, that's really bad soldering. This old power supply certainly isn't clean. Now, there, you got that on there. And the idea is, for example, you might be curious about a particular circuit, and this has caught my eye. Look at this crazy thing here. You can see here, this is the 0 volt output on this power supply, and there's so much bussing going on. Look at this. They've doubled up the PCB traces to take some serious current. In fact, there's even a bit of a wire. That's why these cheap power supplies blow up. Anyway, I'm just going to attach this wire to a random circuit, not that black one. I'm just going to attach it here, which I don't know what it is. It's just a convenient point, and it seemed to have a bit of flux on it already. So now that's bonded nicely. I'm going to turn on our gadget here by attaching our battery. So there. And I think I'm not sure what these do. I mean, this could be the output signal, and this could be the volume. It's going on the input. It's something like that. But I'm going to just put the input straight to the output and see if we can hear something if we adjust these knobs. Well, I can certainly hear a... Okay, so you can hear it's just picking up. It's just amplifying, and that is attenuating it. So that's probably a volume. Now this side, though, I would have expected Oh, yes, listen. It's quite quiet, but you should be able to hear a faint signal. I've been getting a few weird things, really. I'm not sure if I quite understand everything, so I had to break out some different equipment. You can see I have a pocket DSO scope here. I have the batteries removed, are now being powered from a bench power supply. I've hooked the scope up to the speaker output. So now when I touch the input and the output together, you can see, if you're eagle-eyed, and I'll zoom in, a sine wave on the screen. And you can see as I adjust this pot here, the top pot, which I believe is the output level, you see you can turn that off and then bring that up. So that's probably the strength of the signal coming out. And then on the right hand side, or this pot here, I believe that adjusts the amplification on the receiver. And you can see you can drive it all sorts of crazy. So if you recall, my idea was that is working okay. You can hear some sort of noise, you can see something on the screen. And we would just solder this somewhere on the board. Now, when I attach this to the board, because of course I have a ground here, I think I killed something and that I was just basically grounding that signal, which is not what you want. So for example, if I have this here, as soon as I touch it off that board, that sound disappears and goes very quiet. So I'm not necessarily sure that ground point there is a good idea. Again, not quite sure how people use these in practice, but you can see it does tend to get attenuated, but I think we can explore a little bit further. So imagine you've attached it to this point on the PCB, one which doesn't seem to cane it. So if you do, as a sanity check, touch the output to the input, you can see it still works great. So it means there's nothing going through to that earth, shorting it out. Now using this probe, you can see I can find where that signal goes. I'm just going to run it along all these random things. There's an IC there. Hopefully we'll find it's coming out somewhere else on the board. So we found it here. And because of the different volumes, you should be able to hear it louder, quieter. You'll be able to hear it depending. It will change slightly depending on what it's doing. So if it's going through some resistors or capacitors, etc., capacitors will potentially take out the AC component and really affect that signal. You might not be able to hear anything. Just like that. You probably can't hear it. You might just see on the oscilloscope a slight little jiggle there. Interesting stuff. I mean, again, I don't really know the use case of this. But if you do have any sort of RF type oscillation, you should be able to pick it up with this wire and you'd hear it. I mean, this would just act, you can hear it acting as just a regular amplifier. I mean, potentially, what would happen if we can try to get it onto a speaker like this? You might be able to get it to do a oscillate and make a loop. Anyway, so clearly it works. As far as I'm aware, it works. It's doing something. I don't know what you do with it really. I don't know how you use it. I'm not entirely sure. My assumption that clipping it to somewhere on the board and then tracing where you can hear the circuit, the signal going, is how you expected to use it. But that's how I would have thought you would. So if you do know, let me know down below. I could go online and figure this all out, but I'm not really that interested in the using part. I'm sending this off to my dad and he can enjoy it in his hi-fi adventures. Thanks for watching.